Hi, in this video, I'm gonna talk about finding integrals that involves exponential functions and your natural log functions. Okay, so previously we learned that if my f of x is equal to e of x, and when I find the derivative, I will get e of x, right? Also, for my, let's say if my f of x is equal to ln x, and when I find the derivative, I will get 1 over x, right? So in the previous chapters, when we talked about differentiation, we are able to find the derivatives, right? We learn how to find the derivatives. But right now, as we're talking about integration, we're talking about integrals, we have to go backwards. Okay, we have to go backwards. So this is kind of, it's not something that's very new. We did this kind of, we know how to, if we know how to find the derivative, then finding integrals, it's just sort of the opposite, right? So let me just kind of put it down, kind of the rule, right? So if I integrate, if I'm trying to find the indefinite integral of e of x with respect to x, what I get is itself plus a c. Okay, and similarly, if I try to integrate 1 of x with respect to x, I will get ln x plus c. Okay, what we are doing here is just we're going in the opposite direction, finding the antiderivative or the integral. All right, I'm going to show you guys a few examples. All right, so let me go to the next page. Okay, so I have 2 examples over here. Let's look at A first. So for A, I need to find the indefinite integral of 4 over x with respect to x, right? So when we're trying to find integrals, we can always take out the coefficients, right? So I can take the 4 out. So it would be 4 multiply the indefinite integral of 1 over x dx. So the thinking process that we should have is the 4 is just going to stay there, right? So this part, the indefinite integral part, I need to think about, okay, what do I differentiate so that I will get 1 over x? What do I differentiate that will give me 1 over x? Right, so as we discussed in the previous page, when we differentiate ln x, right? When we differentiate ln x, we'll get 1 over x. So that's it. That is my answer. So 4 of ln x. Right? Don't forget the plus c, because we're talking about indefinite integral here. Right? Don't forget the plus c. So let's just find out. Let's just test. How do I know that I'm right? Let's test it out. So let's say if my f of x is equal to 4 ln x plus c. So my f prime x will be 4 multiplied by the derivative of ln x is 1 over x, and then if I differentiate a constant, it becomes 0. So I'll get 4 over x, which is good. Right, matches what I have there. Okay. Now let's look at example B. For example B, I need to find the indefinite integral of half e to the power of t with respect to t. So in this case, my variable is t, not x anymore, but I'm going to approach it the same way. So I'm going to take out the half. So I'll get half multiplied by e to the power of t with respect to t, right? The half multiplied by the integral of e to the power of t with respect to t. Now, again, we need to think about what do I differentiate that will give me e to the power of t. So also that we also talked about this. So the answer would be itself, right? Because when I differentiate exponential functions, I'll get itself. So half of et plus c. That will be my final answer. But just to make sure that we are right, so f of x is equal to half of ET plus C. If I find the derivative of that, f of t, sorry about that, that's f of t. If I find the derivative of that, I'll get half. So if I differentiate e of t, I'll get e of t. And when I differentiate the constant, it'll be 0. So I'll get half of et, which is what I have over here. Okay? So that's it. That's it. We will talk about a few more examples in the next video. For now, I'll stop here. All right? I'll see you guys in the next video. Bye-bye.